Hello there! In this video we're going to talk about survival statistics and how to use the R-Biostatistics survival tool, as well as how to interpret results. Survival statistics can be accessed on the Biostatistics tab. Let's begin by looking at an example Excel spreadsheet to get an idea on how to format our data. There are 4 columns and 30 rows. Each row represents one participant. The first column, time, is the time from when the participant joins to the time of the event or end of follow-up, in arbitrary units such as months. Second column is status, which specifies whether the participant experiences an event or not, in binary. So 0 means no event has happened, whereas 1 means an event has occurred. The last 2 columns are ways to divide our test participants. This can be into arms of a clinical control trial, A and B, which may represent an intervention and a placebo group. Or it can be some other dividing factor, such as the column 6, where 1 may be female and 2 may be male. If we return to R Biostatistics, click Analyze, then upload our Excel file, we can select our variables, time, status, group, and sex, and define each of the parameters. So time is time, status as status, and event, we can choose whether to focus on events which have happened, which would be 1, or didn't happen, which would be 0. We'll focus on 1. And then we can define the group, which can be the group sex. We'll focus on group for now. Under the tab Summary, a brief summary is given, including the number of participants, number of events, and the proportion of events to end censored. Under the tab One Group, a summary of the survival statistics is given for the dataset without segregating it into groups. And under the tab Groups, a summary of survival statistics is given for each specified group within the dataset. This is the area you should focus your attention on. First, we will focus on the likelihood ratio, WOLD test, and score log rank test. These are all global measures of significance in this model. If the p-value is sufficiently low, then the findings of the comparison is said to be significant. Typically, their outputs are similar for large groups of n, although the outcome of the likelihood ratio is generally preferred. Since comparing between groups A and B is not significant due to a p-value of 0.2, we can change the dividing factor to be 6, which has been shown to be significant. Next, we can look at the Z column. Here. This gives a metric of whether the coefficient of the variable being measured, in this instance it is sex, is significantly different from 0. And here it reads 3.38. Underneath you can see the significance code of 0.05. The sign under coef or coefficient here reads 2.74. Since it is positive, the higher the value of the variable, the worse the prognosis. Since sex is encoded as 1 is female and 2 is male, being a male leads to a worse prognosis in this data. Likewise, if the sign under coef was negative, being a female would carry the worst prognosis. Last thing we'll look at is X coef column. This gives the effect size of the variable. Here it reads 15.5. This means that being a male increases the hazard factor by around 15.5. Under the plot 1, a graph of cumulative survival against time is plotted. The survival curve decreases in its characteristic step fashion, which indicates the time at which an event has occurred. Under the tab Plot Group, a similar graph is plotted, except the participants are separated into their respective sex. So the male represents the red line, and the female represents the black line. If you require more information, please see the test description and resources on the R Biostatistic website, or refer to our glossary. Thank you.